The planetary boundary layer, also known as the atmospheric boundary layer or ABL, is the lowest part of the atmosphere. It generally extends from the surface to a pressure level about 850 millibars, though its height varies depending on certain factors, the most important of which being incoming solar radiation during the day. The surface of the Earth forms a boundary for the atmosphere and influences it by way of sensible heat flux, moisture flux from the surface of the atmosphere, such as evaporation and evapotranspiration, and radiation. The wind is generally responsible for the transport of heat and moisture in the horizontal direction, but it is turbulence in the ABL that dominates their transportation vertically. This turbulence consists of eddies, which are swirling vertical motions of air that have many variations in size, intensity, and duration. This transportation of heat and moisture vertically by these eddies influences the diurnal range in temperature and stability of the ABL. There are stronger diurnal variations over land than there are over the oceans. Predicting the diurnal evolution of the ABL is a crucial part of the weather forecasting process, but the ABL also has implications on climate. In addition to playing a large role in momentum, heat, and moisture transportation between the surface and the atmosphere, turbulence in the ABL can impact the duration of mid-latitude cyclones, which means that it can prolong the life of a dangerously strong low-pressure system. There is also evidence that heat flux from turbulence near the surface is what is causing the bottom-heavy warming pattern, meaning that the air closer to the surface is warming faster than air higher up in the atmosphere. As CO2 emissions increase, the oceans will store more heat and become warmer, while sea ice will continue to melt. This will increase the turbulent heat flux at or near the surface, further enhancing the bottom-heavy warming pattern. Though much remains to be discovered regarding the ABL and its implications on the changing climate, the dynamics of it remains a hot topic in research, and hopefully we will soon have more detail as to how the ABL will influence the environment in which we live as the climate continues to warm. For Up in the Air, this is Colby McCabe.